Hello and welcome back. My name is Corey, and you're my rubber ducks for the evening. And of course, this is the series of episodes where we are creating a programming language from scratch using just our wits and a few basic tools. a, uh, a, a terminal window, Vim is our editor, C++, modernish C++, we hope, and Flex, Bison, ICU, Google Test, Make. That's about it. Yeah. So, the last episode, well, we're kind of like in the middle of a big refactor of how we handle strings. And the reason is because ultimately this is a templating language. And we need to be able to say that parts of a template are safe or unsafe or need to be encoded in a certain way, and whether or not that has been applied yet, because you don't want to double encode things. And so as part of that, I realized that when we're building up our output, excuse me, we actually need to kind of save. Save isn't the right word. Well, retain the different parts, the different segments. And as part of that, well, in other words, we shouldn't combine things early. And to be honest, I dreaded this. That is this refactor, because I didn't know how I was going to do it without it being a horribly long episode. And in the previous episode, it hit me like about 5 minutes before I was supposed to start recording that I need to focus on the print output first. And if I convert that to not going directly to a string, a rendered string, but rather save it away as a computed string, then I can use the computed string functionality to create what we need to do here. And I know that probably sounds a little weird, but it makes sense in my head. And so what we're going to be looking at then is we want to continue along this conversion path. So what we did last time was we changed it so that when you say print in some variable, that it has, like I said, a computed expression string that is storing that information. And we now need to change computed expression strings so that when you add to them with the plus operator, that it stores them as an addition to the string itself, if that makes sense. And that's what we're going to jump into. As opposed to just concatenating them together, we're doing what I'm referring to as a deferred concatenation. We're going to store them in parts. And unfortunately, that means that asking for the length of a string may be somewhat slower. But we shouldn't have to do that often. Or doing a substring will actually be slightly slower, because we're going to have to create special mechanisms for that. But that's what today is about, is implementing this sort of deferred combination. So let's get this going, shall we? We want to it was like I'm on the complete wrong thing. There we go. You weren't seeing the screen anyway. As usual, there we go. If I say git log, you see that the last commit was the end of episode 60, which was the previous episode, because we are on episode number 61. Big thing for me. We're on episode number 61, and if I say git status, no changes have been made. This is nothing up my sleeves. 100% live coding, which means you see all my mistakes and everything. And I went ahead and opened this here. This is our documentation that gets generated, because I wanted to look up our Unicode string class. And I just want to kind of remind you that we have a this Unicode string class that has a string where everything is stored in UTF-8 as it's sort of what it's backed by. And then we have this grapheme offsets that we use to kind of keep track. And I don't remember what uString is. Oh yeah, it's a cache of the ICU Unicode string. So these two that are cached are not always what's the word I'm looking for? They're not always saved, right? That the way that they're implemented, they're not always saved, but maybe they should be. Sorry, I'm just rethinking about how I implemented this, and maybe I could go about this a different way. But anyway, okay. Yeah, these are cached values that until you actually ask for the length of a string or ask for a substring, they're not populated. But they're part of this Unicode string structure, this class. And if I just, which our computer expression string stores a Unicode string. So instead of just a Unicode string, if I store a vector of them, we should be good. That's the hope. Or at least the first part. We're just going to jump in because I know that there's quite a few things that we're going to have to change. And we're just going to jump in starting with yes, we're going to need the include computed expression string and the source for computed expression string. And that's where we're going to start. Now, what are we doing here? Well, if we go down to by the way, so what all have we implemented that we're going to have to worry about? We're going to have to worry about the equals, the slices, the way the iterators are. Oh man, this is going to be big. I'm hoping I can get this done rather quickly. So I've got val, and it is a string value, and instead this is going to be a standard vector of Unicode strings called, I'm not even calling them val anymore. Let's call this parts, string parts. Yeah. That's where we're going to start. We've got string parts. And I think get value, where is that used? We're not in anywhere yet. So let's cd source get grep get value. We use it here. And instead of that being a string, I think we're going to okay. I'm just thinking. Just doing a quick little scan through here. All right, so instead of it being a Unicode string, I think it's just going to be a standard string. Get value. Yeah, we'll leave it as get value. And let's just start breaking our compile, okay? So make clean, and how about this? No, it is make clean. Oh, I'm not in the right directory. Make clean. All right, so that's going to get started. It's going to complain at some point. That's fine. All right, so now we've got our computed expression string and where we create it, and we're going to start off with string val, and I'm going to say const string ampersand val, and let's do this arrow string parts dot push back and Unicode string val. That's the first thing. And I'm going back to change my constructor. There we go. This is always should have been anyway, a const standard string ampersand. All right. And now, so for the dump, for the moment, so the dump is supposed to return a string, and I'm going to say string out is equal to, or string out there, for auto ampersand part in this arrow string parts, and say out plus equals part. This isn't quite what we're wanting, but for right now it will work. Return out. All right, so computed expression map. Why is this complaining? Oh, and what is that index? I just need to see where this is. Let's look at the source computed expression map. Line 76. Oh. The issue here is that before I was just returning the Unicode string, and we shouldn't do that. We should have a bytes length directly on the computed expression string. That's what we need. So bytes length. Okay, this is still getting it as a, that should be fine. So we don't have a bytes length. We're about to do that. We're just going to add that in. So we need a function. So we've got get value. We're going to of bytes. What is this going to be? This is going to be a size t. Bytes length const. I think we can do that. And so wherever the get value is. Still not there yet. Okay. There. Should be right after get value, right? Bytes length, size t, and now we'll just say size t I item in this arrow. What am I calling this? I don't remember. String parts. That's it. String parts. Count plus equal to item dot bytes length. Return count. All right, and go back 95. We've got the same issue. That's going to be all right. Does that mean we're still we're breaking back where we thought we would be? I think the answer is yes. It's all in computed expression string. That's good. All right. Oh, we expected something. So line 16. we go. Now, what I think is going to happen, I could just keep going with these in order. Basically everywhere I have a val. Yeah. So let's just start working our way down. So number 29. We're going to have to create another another constructor. I can already see that. So what are we going to take? Instead of a const string val, we're going to take a const Do I need to? I'm wondering if I can do star this without having to. Does it give me one by default? I don't know. We're about to find out. Let's go back to the we're not compiling down to 41. Okay. So we're getting further. So in this case, we're saying, are we equal to true? Now what we need to do so let's just say bool result. No. And all that I'm going to do here is I'm going to say, whoops, fold or equals part dot bytes length. as a bool. So I'm basically converting each one and saying if any of them true, then this is going to be true. And now I just need to know. And why am I saying fold? Because I'm folding the value. That should work. Oh, I need a G. Really? Next one, number 49. Okay. For the is equal, this is kind of going to be the same thing. Oh, though. This one is harder. Because I want all of the if I look at the dump, right now that's I can call that for now and just compare that against. Okay. Let's get, I want to make sure. Okay, we're up to number 58. This is where stuff is starting to get hard. So instead of this arrow val length, where did I put that? Well, there. I'm going to say a size t count is equal to 0 and count plus equals the bytes length. Okay, so count is going to be the number of bytes. So what is I? Oh, it's as a, okay, that's fine. Count. Count. Okay, I can't do my lovely little ternary expression anymore. It only works when everything is nice and okay. So here's what we're going to have to do instead. We're going to have to say if I is greater than or equal to 0, else something else. What goes in here? We'll say index is greater than or equal to 0. And now, if I is less than integer t count. I don't need an else because I'm going to be returning something. But so if I is less than integer t count, this is where the work's got to be done. We're going to have to collect the string parts. Otherwise, let's just do this. Okay, otherwise, return there. Else, if negative I is less than or equal to integer t count, collect the string parts. Okay, we're almost there. We just have to do the hard part now, and that's the collect the string parts. So what is this going to look like? First of all, we need to have a vector of Unicode strings, and we will just call that new parts. And now we will say, this is the index, isn't it? Yeah. We have to find, so size t count 0. And what we're going to do is we're going to say for auto ampersand part in this string parts okay. So if the count plus the part dot length, and that should be right, and we can compare that against the length in graphemes, yes. Okay. If that is it greater than or equal to I, make our lives easier. And we're no longer going to call this count. We're going to call that total length. Total length, okay. And instead of size t, we're just gonna integer t. All right. So now we're gonna go through, we're gonna figure out what the total length by adding together the bytes length of all the parts. Nope. Not bytes length, length. Yeah, because we're counting graphemes. An index is an index into the graphemes. So now we're saying if I is greater than 0, if I is less than the total length, okay, now we need to figure out where we are in the string parts. And so there's a reason I'm putting this here, but we'll get there. First of all, count. We're going to go through each of the parts and figure out if the current count plus the parts length is greater than I. So let's say, and what is I? I is my index. So if I want byte number 1, and I'm in the first one, and it has a length of 1, my current count is 0, my parts length is 1. I'm going to have a value of 1 and 1, and that is not, it needs to be greater. If it is greater than I, then the index grapheme is within the current part. Okay. So the new parts is going to be that, and now I'm going to new parts push back, and I want to do part dot subster, and I need to know how far. Well, count is where I am. So let's say I'm at 0. I is where my target is. So would it be I minus count? So count's how many I've passed already, basically. That's where I'm going to start, and I only want 1. I actually think that that's correct. Okay, and then, just to get myself see a little bit more of this. Return collected make computed expression string, and I need to be able to provide a computed expression string of new parts. I don't have a constructor for computer expression string that takes a vector of Unicode strings, but we're about to. There. Else count plus equals part dot length. And if I get to the end and in fact, it's impossible to get to the end because okay. That should all be right. Sure. What is this section doing? This is find the index grapheme. Okay. How do we collect the string parts? So at this point, do I have index is less than 0? Sorry, I want to put that period there. So what do we do at that point? We want to convert that into I is an integer t. Okay, so now I is going to be equal to total length. And why did I put a period there? No idea. Wait, is this all I had to do? into an index from the beginning. And now I'm going to say if I is less than or equal to 0, because I've now done that. So the only way it would be less than or equal to 0 is, say there's 3 graphemes, and I ask for -1, that would give me number 3. If I ask for -2, it will give me number 2. And if I ask for -3, it will give me, well, wait, I'm saying that slightly backwards. In fact, let me just write it out, just because it's probably easier to follow. If I ask for -3, that will turn into a 0. If I ask for -2, that will turn into a 1. If I ask for -1, that will turn into a 2. Yes, so what happens if I ask for -4? Well, if I've only got 3, that's going to be a -1, and that is going to be out of range. So that is all correct. Okay, so I need to do the exact same thing here. And let's copy that impossible to get here. Okay. I think that works for the... Oh, and all these need to go away. So all of that work that I had done with the val substir, blah, blah, blah. No, that's fine. Okay. Am I missing a closing? Yes, I am. There. Okay. That's a lot of work. Guess what we get to do now? The slice. I'm just saving this to see if we're compiling anywhere near. If we have moved forward, line 68. Count. Count is an integer t, so this should also be an integer t. And if I had to do it there, I'm going to have to do it down here as well. All right. 132. Okay, so all of this is compiling, or all of that will compile, I think. Wait, 132, yep. So this is the first place. Okay. What are we doing here? Thank goodness I wrote comments. Verify that the skip is either a default or an integer. That's fine. Skip is an integer. And we've got converted skip. Return the... Okay. Verify that the skip is not 0. Okay, verify that the begin is either default or an integer. Okay, so we need to know the total at this point. So that's line 128. So I need to get the total length right here. Go down to 128. Compute the total length. And yes, I know I should probably cache this and all that. That's a later episode. Right now we're just trying to get this to compile. This is a big lift day in terms of what we're writing. So total length, okay. Nope, deleted too much. Total length. Okay. So this is not going to be correct. In fact, we're going to create a vector of, what did I call it? Unicode string. And we will call this new parts. And here it's going to be new parts dot push back. Now, skip is positive. This is not right, by the way, because I can't do new val subster I. Can I do this subster? No, not yet. Okay. Sorry, I went past where I was looking. I mean, this looks like it would work, but it won't work. So here's the problem. let's say the skip is positive. What if the skip is 1? Well, I should be able to grab them in chunks, right? That's the goal. But what if it's not? What if it's a skip of 2? Then I can only grab one grapheme at a time. So really I need to check. So if the skip is positive, that's fine. Now I'm going to say if conv skip is equal to 1, copy chunks at a time. Else copy grapheme individually. There we go. All right, so what does it look like? Copy chunks at a time. Well, we're going to need to go back to have the length there. Where am I doing this? It's in the slicing. I need the indexing code. Okay. All right, so I've got a couple things here. If now my okay, so if count plus the length is greater than 1, that means I'm starting here. What if I've already been running? What if oh, I said it's greater than I, but that's not what I need. I've got where do I start? Conv begin and conv end. Converted begin, converted end. Okay. So if just back up a little bit, and I'm thinking out loud. So if the count is greater, and count, remember, is which one I'm on. 0, 1, 2. So let's say I'm on 0. The first part has 3. The next time we go through, it'll be a value of 3. And if that is greater than conv end, break. And I'll just say are no more parts to collect. All right. If count is greater than or equal to conv begin all or part of this chunk should be collected. How do we know? Well, if it's all going to be count versus what if, oh no, wait. No, this is fine. So if count plus part dot length is greater than I'm so worried about off by one errors at this point. Conv end, basically. So if I've got a count of 0 and I want to go until 3 and my part's length is 3, 0 plus 3 is 3, then I would take the whole thing. But if okay, the easier way, count plus part length is less than the end, then all of the chunk should be collected. Okay, and we'll do that as new parts. Yeah, new parts dot push back part. Else, so that means count plus parts dot length is, instead of less than, it's greater than or equal to conv end. What would that mean? If it's greater than, that means I need less of it. Do I have Unicode? Do I have a substir? I do. Oh, but it returns I don't like that. We'll leave it for now. So what am I thinking? So if count is count plus part length is greater than or equal to conv end. So the equal to is what's kind of, so only part of the chunk should be collected. But it's, yeah, so if I've got a count of 0 and the part length is 10, but I'm supposed to stop at 3, this would be a case, right? And so what should I do? I should do a new parts dot push back part.subster. How far into it? That would be 0. How long? Conv end minus count. That should work. What happens if I have it's equal to? If I'm at 0, my length is 3, and I want to end at 3, and this is up to but not including. So I should only get 2. So conv end is 3 minus count, which is 0. I'm getting 3 things. I think it should be minus 1. I think that's my off by 1 error. Okay. And then break out of the for loop. All right. So, I know it feels like I'm rewriting all this stuff. Well, I am. I'm glad we have unit tests, but stuff is going to break. All right, so if count is greater than conv begin, all or part. If it's less than, conv begin, what could be the case here? Else something. What would it be? Count is before may need to be skipped or only partially included. All right, so if count plus part dot length is less than, so count is 0, part length is 3, and we're starting at 3, but that would be at 4, right? Number 4. Oh, so that's another potential off by 1 thing I wasn't thinking about. Okay, let me do this and then I'll go back and double check my math earlier. So if count is 0, part length is 3, and we want to start at 3, for example, what would it be? If it's less than conv begin? Okay. That means, so if it's 0 and has a length of 3, that means it's taking up 0. Means it's taking up 0, 1, and 2. Right? And if I'm beginning at 3, it's not going to include that. So count plus the part length. If it's less than conv begin, should be skipped entirely. And all that I need to do is count plus equals, nope. Yeah, I'll do it. Count plus equals part dot length and continue. All right, so now I'm down here and I'm going to say, so count plus part length is greater than or equal to. So maybe there's a 2 or whatever, but that means the chunk is starting. Is starting. Or the starting in this chunk. Okay, it's starting in this chunk. Now, before I move on, I want to go back and double check what I was thinking about. So, if my skip is equal to 1, I need to copy chunks at a time. So we're going to try to collect the string parts. We're going to say count is 0 for each part. If count is greater than the end, I'm definitely past. Now, is that true? Yes. What if it's equal to conv end? I should also break. Okay. Now, if count is greater than or equal to the begin, that means, so all are part. So if count is greater than or equal to conv begin, if it's equal to conv begin, okay, that means we're starting on the first. Or if I'm further into it. So this catches the case where count and conv begin are the same. Okay, so all a part of this chunk should be collected. Count plus the length is less than conv end, all of it. Okay, is that correct? So what I was saying earlier is if I've got a 0 and a 3 and a total length of 3, so count is 0, my length is 3, and my end is on 3. Then it would be going past it, so count plus length. Oh, wouldn't that be the opposite? Shouldn't it be greater than conv end? If my current location plus the amount that I have available if that's less than the end. That's what it is. This is how much is available. If that's less than end, okay, so 0 plus 3, yeah, this would have to equal 4 because this would be bytes or location 0, 1, and 2. Oh, no. Shouldn't that be an equal? Now that I'm thinking about it. Zero plus 3 is going to be 1 larger than it needs to be. So I think we've got to have the equal. So if count plus 0 plus 3 is less than 4, then all of it. But what if this is a 3? We would have 0 plus 3 is less than or equal to. Should all of it be collected? Yes, because all of it is 0, 1, and 2. And it's still less than or equal to. Okay, so that is correct. Else, only part of the chunk. So what would that be? Say I wanted 2. It's supposed to end at 2, which means I only need 0 and 1. Okay, so only part of the chunk. So I'll push back the part subster of 0 because I know I've got the beginning, and conv end, which would be in this case 2 minus the count 0. Oh, and I've got minus 1 here. I don't think that that's right. 2 minus 0 would be 2. Oh, and if yeah. That's right. 2 minus 0 is 2, which means I need numbers 0 and 1. Okay. All right, now let's go down to this one. This chunk may need to be skipped or only partially included. So this means that the second half, by the way, just humor me for a second. There, just moved it in 1. All right. Or only partially excluded. Okay, so that means we're doing not at the first. Why? Because that would have been in here. So the beginning of the chunk will be included. And the question is, do I need all of it or part of it? That's fine. The second is chunk will not be included. This chunk may need to be skipped or only partially included. Okay, so what am I saying? So if the count plus the length, 0 plus 3, is less than wherever I'm supposed to start, let's say I'm supposed to, is this what I'm I'm doing? If I'm supposed to start at 3, it should be skipped entirely, yes. If I'm supposed to start at 2, 0 plus 3 would not be less, so the slice is starting in this chunk. That would be correct. Okay, The question is now, no. Well, okay, so the question is, if the chunk is this long and we're not starting at the beginning of it, do we go to the full end of it or do we only get part of this chunk? That's the question. The slice is starting in this chunk. So, sorry. My eyes are drying out. Wonder why. It's only, oh, it's midnight. 03. 12:03. If count plus part length, and again, now I'll use 3 as the end. Well, we've already done the logic. Plus part length is less than or equal to conv end. Then we say until the end of the slice the end of the chunk. And where do we start at? It's not going to be 0. It's going to be we're starting if it's at say if this chunk starts at 0 and it has a length of 10, but oh wait, I don't mean that. I mean if our count is 3 and I'm saying it in a backwards way. We just need to say, okay, where do we start? How far into the string is it? I shouldn't do this while I'm tired, if that's okay. So count is my current position, and it's going to be midway into the string, into the chunk, if I can, into the part. I need to know how far it is. Well, no. Count is not midway into the string. Count is less than the start of the chunk, and conv begin is somewhere. So count may be 3, conv begin it may be 5, so start with the fifth one. So if I'm if 3, 4, 5, right? So 0, 1, 2. It's conv begin minus count. And how far? Convend? Sure. I could say the maximum of whatever, but if I go past, because this is a subster, if I go past it, it's not a problem. So what did I just write? Okay, and I'm evidently missing a parentheses there. Now at this point I will count plus equal part dot length and continue. The slice must end before the You know what? Do I even have to do that? I don't think I do. I've been going to all this trouble, and all I need to do here is say, how long do I want? Well, that's going to be yeah. If I did this, if I had conv end minus conv begin, that would be the length. And so if I have more than that here, unless I've got it off by 1, right? It might. So if my begin is 5 and my end is 10, okay? 10 minus 5 is equal to 5. But what bytes would I have? I should have 5, 6, 7, 8, 9, which is 5. Yeah. So that's right. So I don't think I need anything else there. It's a lot of work to just say. Now, why are we doing this? Because a skip of 1, which I actually think is probably going to be more common than we think, because do people really need to reverse a string that often? Maybe, but I think most of the time it's just give me the first 3 characters or the last 3 characters or whatever. And that's going to be a run, and you might as well grab it in one chunk. So if you can. So that's what this is. All right. So if the skip is equal to 1, Return, finally, make a computed expression string of the new parts. Is that right? If the skip is equal to 1, what I'm wondering is if I should put this here and now say skip is greater than 1, and now just go from here, because this takes a completely different type of logic. I still have there, just folding that. I still have the converted skip, begin, and end. What I need to do is I'm going to have an index. No, I mean an integer t, and we're going to say the count. Sure. While count is less than current part. Okay. No, I don't think I need to do that. I think I can at least do it this way. For auto ampersand part in this string parts. Okay. And I'll start off and I'll say if count is less than conv begin, count plus equals part length. Continue on to the next one. Is that right? No, it may be. So I should say if count plus part dot length, count plus, and it's got 5 characters. So it's starting at 0. So if 5 is less than where I should be starting, should that be less than or equal to? Again, the reason I'm thinking is because if I'm starting at 0 and it has a length of 5 and I want to start on 5, well, 0 through 5 has bytes or graphemes, 0, 1, 2, 3, and 4. And so I should skip it entirely. It's not until it's greater than 5 Yeah, because that's the 6th grapheme. Okay, that's right. Skip this chunk. All right. If I'm arguing with myself. That's the problem. And I know that that doesn't make for very entertaining anything. But my thought is I need something, I need a variable to keep track of kind of how many times I've skipped forward. So if I've got a skip of 8, right, I need to know what the last number I did was. Next index, and that will be conv begin. And what I want to know is if count plus part.length is that right? I basically have 4 variables here. Well, I've got a lot more than that. So count is the beginning of the current chunk. Conv begin is should I even use conv begin? I think I should use here next index. And is that right? Again, I'm second guessing myself, but if I'm starting at 0 and I have a length of 5 and my next index is 5, then that means I've got numbers 0, 1, 2, 3, and 4, which the next index is 5. So if it's less than or equal to next index, I need to skip it. All right. So now, if the next thing I'm checking is within the current chunk, and I keep wanting to spell chunk with 2 C's. Don't know why. So if count plus part length is while count plus part length is greater than next index. Is that right? And again, so if I've got a count of 0, part length of 5, my next index is 5, it's going to, yeah, skip over it. But in fact, does that mean I even need this here? Can I just do this entirely? Because since it's a while, it's going to say, well, is this greater than next index? And if it's not, it's just going to skip and go down to count plus part length and go with the final step being return garbage collected. And then that means I can probably do this as an else. Get rid of that. Okay. Now, what would this look like if my next index were 3? I would say this arrow string parts dot push back part dot subster, and what is it? So grab one character. Next index plus equals to conv skip. Sorry, thinking again. And what will this do? This will say, so while the thing is in the current chunk, push back that the substr for that and do the next index, blah, blah, blah. Skip to the next one. And as long as it's in this chunk, when it's not, okay, add something to the count, go to the next. Okay, that should actually all work. Now I have to worry about when the skip is negative. It's almost like we could do it forward. Because that's the problem. It's like if it's negative, yeah. Okay, let's rework this a little bit. So what I'm going to do is we're going to reuse all of the work that we did with the skip. All right, how we're going to do this. So we're going to say if the conv skip is greater than 0, we've got all of this. Let me close that up again. I'm going to put this line back because we're going to make use of it. No. So what I'm thinking is, let's do this. Okay. Skip is so skip is 1. Special case. It's a 1. Now we're going to say flag to can I do this? Indicate that the final results should be reversed. And this is a Boolean is reversed. And that's going to equal to conv skip is greater is less than 0. Okay. Now I no longer have to do this. I can say all right. So what's the problem with the negative? So let's look at conv begin and conv end. Okay. Compute the total length, that's fine. Skip is not 0, so this gives me the skip. Okay. verify that the begin is either the default or an integer. So the begin is a default value. If the begin is conv_skip is greater than 0, else it's total length minus 1. I'm going to count down. Okay, so the problem is that my test for the skip is negative versus skip is positive. So what I want to do is I want to change my conv I'm going to have a new int actual begin that's going to be conv begin actual end, which is conv end, and actual skip, which is conv skip. Now, if conv skip is, forget that, if is reversed. Okay, if it's reversed, I'm going to compute exact begin and end values not computed, but compute exact begin and end values by the forward algorithm. Can we do that? Forward algorithm? Sure. And then later reversed. Okay. So if this is the case, then actual skip will equal negative actual skip. And in the perfect world, actual begin and actual end would be reversed, but, well, the problem is end is where we want it to be. So let's say, okay, at this point, let's say actual begin is a 1 and actual end is a 5, and we want a skip of 3. what are the numbers that we want coming out of that? Well, actually, yeah, 5 should definitely be a number. So should, well, I'm saying it in reverse, but 5, 4, 3, 2, and then 1, 0, -1. You know, that's, and so 2 should be the start. 5 should be the end, but it's not the, it needs to be +1. Right? Because in the end, if we have a 1, if we had start at 5, colon, 1, colon, -3. That's what I should have a -3 there. It should be, I should have 5, then 2, then nothing else. So what I need to do then is in reverse say, oh, no, go from 2 to 6 with a skip of 3, which would give me 2, 3, 4, 5, and then that's it. That's what it should be. So how do we go from this to this? Well, the new end hello? Oh. Actual end we're going to increase by 1. Simple enough. The actual begin, however, needs to be I have to think about this a little bit. Five minus 1 would be 4. Divided by 3 would be an integer division. Times 3 would give me a 3, and that would give me the 2. So I think it should be that actual begin should equal to actual end minus actual wait. So I've already swapped these, right? Yeah, actual begin and actual end. And actual skip is negative. And that's fine. So actual 5, 1, -3 will become actual end is 5 minus actual begin divided by actual skip times actual skip. And then actual end is increased by 1. In fact, I'll just write that as an example. So what did I say? 5 colon 1 colon -3 will become 2 colon 6 colon 3. Two and 5. To be reversed later. Actual end. Minus actual begin. 5 minus 1, 4. Divided by the actual skip times the actual skip. Is that right? If I had said 5 colon 2 colon -3, what should be returned? 5, 4, 3, 2. But 2 should not be included because it's up to but not including. Yeah. So minus 1. 1 fewer. I always got to check the off by 1 errors. All right. All right. If I get this far, I need to go to the interwebs. What is the best way C++ reverse a vector? But does that give you a new? C++ reverse. Reverses it in the range. Okay. So we'll just say if is reversed, then new parts. Is that right? New parts. Yeah. Dot begin. New parts dot end. Create the new string. All right, now I know I'm going to need pound include algorithm. And now hit save and it's going to tell me everything that I got wrong. $187. $202. I thought I'd already done these, but oh, 213. What is I? I don't remember. I don't know what I'm doing here. That's probably conv something. What is I? We don't have an I. Why don't we have an I? No more parts to collect. Beginning of this chunk of parts. Is within the current part. Oh, is this... Sorry, I forgot what function I was in. I'm in slice. Did I steal that from index? Because that's where I was using it. For each part, I've got the count, which is the start. This is a special case where conv skip is equal to 1. I think that's a copy and paste error. I mean, I probably would need to go back and look at the recording to find out. $247. Oh, 249. Shouldn't be this string parts. It should be new parts. That's why we use const. Okay. Finally, we're past all of that. What about iterator next? Do I have a function for length? I don't think so. Where are we? $269. I think index. So, what am I pondering at the moment? The problem is the iterator next. What I need it to be is return this arrow dunder index make computed expression integer index? I think so. See if it gets past line 278. Nope. Well, there. Okay. In order to add, I can't just return my value plus the right-hand side val because val doesn't exist anymore. They're vectors of Unicode strings. And so I've done this before, but I don't remember the fastest way. C++, combine vectors. Well, I mean, it's saying Java, but yeah, it's just saying do that with the size merge. First begins first in, second begin, second in, vector one begin. I think I've done that before, and it's in algorithm. Okay, pretty sure. So new parts. Its size plus RHS dot string parts size. Okay, we reserve it, and now merge this arrow string parts dot begin, this arrow string parts dot end, RHS dot parts dot RHS dot string parts dot end, and then where are we putting it? New parts dot begin. No, undo. Actually, What did I mess up? Oh. $295. Okay, yay. That was good. We will all right, and we're going to say this. Yeah, we're going to have to do this total length thing a lot better. But instead of dot length, let's at least call bytes length. Just in case it doesn't need to actually compute everything. All right. 310. Good. We are making progress. What I think we're going to do is just take the coward's way out and say dump. That got us through that one. Okay. The equal, I think we can do the exact same thing. Just use dump. We're going to have the same problem with the total length. No. We're going to use star this. Okay. Get value. I think this is going to be a problem. What should get value return? Does anyone use get value? I don't think so. So if we say it returns a vector of Unicode string, but a const vector of Unicode string ampersand, and return this string parts. And I'm going to need to change that for get value. All right. Where does that put us? 360. Making progress. Yeah, that won't work. Don't I have a dot length on this? I have a bytes length. Can't believe I don't have a length. I've got to have a length. The number of bytes length. All right. Next. Where do we have bytes length? Right here. 7. There. Now we're going to have length. All right, now no longer needs to be get value length 368. It should just be length. Okay, 374. So the plus equals computerized expression string How do I append? Well, it's concatenate, really. I mean, this was merge, but so what I want here is I want to, append vector to a vector. Append. So it's the idea of I vector 1, I vector 2, insert at the end. Okay. Probably shouldn't have closed that. The way my memory's working. It would be this arrow string parts dot insert this arrow string parts dot end. RHS is a computed expression string, so I have dot string parts dot begin, RHS dot string parts dot end. That should work. Work if I spelled stuff. RT parts. Okay, now it doesn't like the way we're creating something, so let's see what this is. Because we don't have a vector of Unicode strings to create a computed expression string. We need to provide that. There. And what we'll do is we will say this is going to be a vector of Unicode string ampersand string parts. All right, and we need to add that construct a string result from a objects. Parts, we will say the see if it likes that. Almost everything. Okay. it doesn't like that. Where did I use computer expression string line 280? There we go. And index is a size t, so it needs to be an integer t. Okay, now we actually get to do bug fixing after 2.5 hours. Oh, I didn't like the insert. In program execute. Oh, because I'm using get value. That's why. Okay, that's fine. That's under source. Program execute. Line 214. What do we do in here? This is in the opcode map. Okay. We're just going to use dump. Okay, so something's looking for get value and it didn't get rebuilt, which means I'm probably missing a dependency in my makefile, of course. Simple enough to just tell everything to recompile. I should get a compile error. I would think it's probably in my tests. Okay, how did it? Computer expression. Line 127. And this is in, oh, it's in the dot, it's in the period. Probably another instance. Computer expression map. Which again, all these are, I bet it's because it's, yeah. Expression map. Line 78. S is the string dump. And it's going to happen again right here, I know. Okay, map is compiling. Invalid pointer. So let's see. We didn't touch the Unicode string, so that is still compiling. Singleton object pool is fine. It's this, but we don't know where. was a free. Why a free? GDB build apps test. Run that. Backtrace. Okay. Kill. Malloc free. String is a space. Okay, this is merge. Okay, the first place though, is this the first place I'm seeing my code? Basic string, Unicode string .hpp line 58. So edit, include really? Unicode string, line 58. Well, that doesn't tell me anything, which means it's probably a default constructor of something. It's an assignment. Can I really tell anything else? Wait. Oh, so it's on the operator plus when calling merge computer expression string 290. Just didn't go far enough. So I hit Control Q. That's all the stuff we changed. Vim, where are we in Vim? We're looking for computer expression string. Computer expression string .cpp line 290. So we're merging. The question is new parts is empty. Is that the problem? Okay. I want to look up the C++ merge. Not merge sort, merge. Documentation, please. Thank you. She's sorted into one sorted. And where is this? Yeah, I don't want to sort. I want to... where's the forward? So I'm thinking... You know what? I'm not going to work myself up over this. What I'm going to do, it is reserved. In my... Where is it? Insert. $290, so... Trying to remember where I did the insert. Insert. New parts.insert. This string parts. I really feel like this needs to be an R end and R begin, but let's look at the vector. Yeah. Okay, so insert new parts end, and it will be and then there should be in the other order. Forget the merge because it's not a sort. And so create a new vector to hold the concatenation. So we're starting with string parts begin, string parts end. Oh no, of course those wouldn't be reverse operators. All right. Q, yes. Rebuild some stuff. Still don't even know whether or not our tests pass. And we have an infinite loop. Oh boy. So in fact, now I'm kind of curious. Htop. No? Not an infinite loop? Oh, wait. Maybe I just had scrolled. Oh, no. Okay, so something died on me. Let's see what's happening on line 608. So edit test 608. These are my indexes. So I expected it to be CBA ABC, and it came out as CBA A, but it didn't get the B and the C. Okay, so that's my reverse indices. Computed expression string, where's my slice? Slice. Oh wait, no, that's slice. I need index. Else, okay, index is less than 0. Okay, get back up to it. There we go. All right. I just want to see what it's doing. Index 0, then 1, then 2. And that didn't do what we expected. The question is why? Okay, there's some interesting things happening here. First of all, this is obviously trying, and I will open this back up and say htop. I'm probably filling up some memory. I am. And then it will exhaust the memory and die. So something is happening somewhere with that. I'll just let it keep going. I'm not too worried about it. index 0, 1, 2. These are negatives. And if we look at that test, we got through the 2, 1, 0 and realize what's happening. We're printing and we're adding these values. So for some reason, the negative 3a worked out. The negative 2, which is an index of 1, did not. So when I have the index of negative 3, I say if I is less than or equal to 0. Oh. That doesn't make any sense. I don't need this if anymore, I don't think. No longer impossible to get there, so... Those tests passed. I still got a broken loop somewhere, but those tests now passed. There. Okay, so that's fine. That's working. 629. So by the way, look, all of these are now working. So now 629, index out of range. When it's a negative 4, it should have been index out of range. Okay. So, index out of range. Why didn't we get there? Because this should be the opposite. That's why. If it's greater than or equal to 0, then fine. I broke something else. That happens. Say, Corey, why are you laughing? Because I'm tired. It's almost 2 a.m. Yeah. So it's running. The bad allocation. So it ran out of memory. In expression string slice. So that makes sense. I've got an issue with my slicing. But that means all my other tests have passed so far. Whoops, wrong window. So it is just the first one in the string slice. And what we're going to do is, see, there's a lot of string slices in here. Let's just see if it dies on the first one. Again, just looking to see if it fails on the first one. Which is a lovely little thing where we're just copying. Looks like it is. Okay. So let's go to a slice. And we'll start off that we're going to say cout conv begin. Conv end. Conv skip. And then inline. Just want to see where it is. Zero, 3, and 1, and 0, 26, and 3. Oh. Wait, what? Oh, well. Do those come from a later one? When does it slice? You know what? Fast way is to say /build apps test the ranged 4 and string slice 0, 3, 1. Oh, because that's the defaults. All right. Zero, 3, 1. That would be the defaults. 0, 26, 3. I guess in the range 4. Yeah. Okay. All right. And that passed, by the way. Notice yeah, those are passing. So I'm just going to go down 2 because, well, why not? We have a lot of tests to do. I bet it's failing on the -1. What do you bet? Yep, on the 2, -1, -1. All right, so 2, -1, -1. is reversed is going to be true. If it is reversed, okay, so actual begin, actual end, actual skip. See what that gives us. Should be the last two colon things. There we go. So two -1, -1. Yeah, it's killed because memory. 2 -1, -1, 2 3 1. So when it's a -1, it should be a 2 to the beginning, which would be -1, 1, which means it should have been start at 0. To 3. Because there's 3 characters there. So it should have started at 0. So the actual skip did in fact make it there. The actual begin is conv begin, which is 2. Oh. So the problem is that, yeah. I'm trying to do clever stuff here. What should it be? Colon, colon, -1. When the string has 3 graphemes, two three colon no 2 colon -1 colon -1, which becomes reversed to 0 colon 3 colon 1. All right. So how do we get this? Well, it's not really. It's 0 minus 1. I'm going to put that 0 minus 1. Negative 1. Okay, so up here, just folding that out of the way, when my first thing I do, get the skip and make sure it's not 0. Get the length. Figure out but they're always expressed as positive numbers, right? Except for that negative 1. I want to know, is it greater than 0? If it is, oh, that's if it's default. If it's an integer, then I want to know, is it greater than 0? If it is, leave it. If not, so it's converted to a positive number. Okay. And I know this probably isn't very much fun. And you're probably screaming at your screen. Like, I'm sorry. Like I said, this is almost like a second job at the moment. So just have to figure it out, and I'm tired. That happens. The skip, we're just flipping it around. Actual begin and actual end are flipped around. The whole point of that is just I want to see it again and see it before I make the changes and then after. So 2, -1, -1. Well, of course they're going to be the same. Why would I think that they would be anything different? 2, -1, -1. Yeah. The actual skip becomes 1. Begin and end swap. And is that right? Actual end gets a ++, so that's why the 2 becomes a 3. The problem is the -1 needs to become a 0. And it's the actual end minus actual begin, which that should be a we've swapped them, so the actual end should be 2. Wait. Maybe that's it. Maybe I want to see it at this point. Yep. Okay. That 2 becomes a 3. That's right. So it should be actual end minus actual begin. And that's 4 minus 1, 3. Divided by, so it becomes a 3. Yeah. Actual begin. Actual skip is 1. Divided by 1 times 1. Shouldn't change. 3. So I'm doing something wrong here. Actual end is 2 minus negative 1. So 2 plus 1 is 3 minus 1, 2. That's why. What should it have been doing? Should have been giving me a 0. Should that be a plus 1? Is that my problem? Well, okay, that's really messed up now. Actual end is 2 minus 3. The problem is it needs to be actual end minus all of that. And I probably have to go back to the negative 1. Zero, 3, then 1. That's the right numbers. Okay. That's the right numbers. Now, perform the skip. It's probably this while where it's dying. So count plus. Do you see the problem? Now we're to the 0, 3, 1. It's probably where it's hanging now. But we can deal with this. Okay. So in fact, yeah, this is wrong. Trying something else. Oh, there's going to be. All right, so let's think about this. So next index is always going to be at the begin, which in this case it's 0. And now this is to iterate through the different parts, while count, which is also 0, plus the length, while that is greater than next index. Or should it just be while count is less than or equal to next index? Because count is something that blah, 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 it goes up and up and up and up and up. But if the count next index is going to skip ahead, skip ahead, skip ahead. And when whatever I'm asking for, the next index is beyond whatever the current count is plus the length. So if the current count is 0 and the length is 5, and I'm looking for number 4. In fact, let me write out those numbers. If 0 and 5, which means it has 0, 1, 2, 3, 4. All right. What values for next index should I still be processing? 0 through 4. So while these numbers, 0 plus 5, which is 5, while that is greater than next index, because once next index becomes 5 or more, yeah, that seems correct. And yet I guarantee this is where it's getting finished. And I'm just going to see out 1 inline and see out 2 inline. I'm expecting to see a lot of 2s. Never getting out of there. Okay. See out next index. Conv skip. And then count plus integer t part.length. Oh, look. We just keep growing. Why? Because the number is negative. It should not have been conv skip. It should have been actual. You know what? There. Just save it. Compile it. We still have a failing test, but we've got a lot more passing than were before. All right, so on the wrong side, there we go. So we don't need the cout 1. Finished. That's probably fine. Don't need to cout. So we've got the actual begin, actual end, and this cout. And what line is failing? It's 662, which is okay. And what are we doing? We're doing a slicing by -1. It is just getting the period. It's not getting the first. So it starts off as the $ period, and it should end up with a period followed by the $. And it's saying it's only getting a period, but then it's giving me everything that has a period all the way to the $. So as I'm going through, I'm couting the next index, which it starts off, oh, excuse me, this is the actual begin. Actual end is 26 with a skip of, wait, skip of 3? The skip is a -1, which should have turned into a regular 1. Oh, no, wait. That's later ones that have passed. This one is this. 0, 3, 1. That's correct. Okay. So 0, 3, 1, and then do we have any other couts? No. We've got a 0, then a 3, then a 1. Okay, so the next index is 3. Why? Actual skip should be 1. Oh, because I'm starting at conv begin, not actual. Well, so far so good. Might as well just run them all. Oh. Okay. So 690. I've only got 2 failing now. This one, which is 117 and 2. Okay. 117, 2. And this one is a skip of 2, so 1 to 17 to 2. It's in the same area. This one. Okay. 117, 2. Just running it again. A little bit better debug detail. There we go. 117, 2. So we start off 1, 3, 5, 7, 9, 17. Why didn't we stop at 17? or 16 rather. We went all the way up to 26. So while and next index is less than actual end. That's going to make a difference. Everything's passing. So range sanity checks. Actual begin is equal to the maximum of actual begin and 0. Actual end is equal to the minimum of actual end and where's the total length? Where are you? I know I counted you up. Total length. This should get rid of things like those outrageous numbers. Yeah, that looks right. All right. I think we're to a stopping point. Oh, I've been dreading this particular episode. I was hoping I could get it done in an hour and a half, and then nope, we're almost 4 hours in. I have to work tomorrow. And I do work, I promise. Just doing our lovely recompile. Everything's passing. Yes. All right. Let's see what changes lurk. We've added a few new methods, right, to get out the to construct a computed expression string, to get a few values, length, the bytes length, the string parts, using dump in a couple places. What I don't like is how we're not caching the length, and we have to use the length a lot. We have to compute it over and over again. That's not good. So that's an optimization. You may have noticed that we're still at 5 milliseconds, and this is without any optimizations. But that's, yeah. I don't like that. Uh-oh. Where is this? What file is that in? The string slice. Oh, and that's where I didn't remove that code anyway. So, source, computed expression, string. Let's look for slice. There we go. This right here. Check this again. Code is definitely more complex. So refactor computed expression string to store to concatenate strings into chunks. There are smarter things we can do. We can right now it's just blind dump one in. We could say well, no, it wouldn't make sense for me to tell you about it now, because right now you'd say, well, why don't we just do it all the time? And there are basically going to be different types of Unicode strings. That's what we're getting to. The ability to be able to say, this is a Unicode string, but it's meant to, it's safe. I trust its contents, versus this is a Unicode string, but I don't trust its contents. And then you don't want those to mix together. So that's why we're doing this work now. And later we could say, well, if I've got the end of a safe string and the beginning of another safe string, I could just add those together and store them as one big safe string. We'll consider that. But for right now, that's good. Okay. Into chunks. Using chunks internally. That was a lot of work for only 200 lines net gain of code. We're going to remake our docs-pdf. Pretty sure there's significant changes. You can hear my computer. I know you can hear it. That's pretty loud. What episode are we on? Episode 61. And we need to tag it. It's there. And we normally end up checking this. Yeah, I'll just see how we're doing. We've passed 3,000 lines and comments. But main thing is this is working. And you know what? So it's telling me, well, this time it ran in 4 milliseconds. I'm curious if in my make file, if instead of -G and that, if I just put 03 and make clean, make test -J8, just to try to get it to compile quicker. My computer's probably really going to sound like it's taken off, of course. Slows down at the end, because now it's got to put all of those together. Yeah, I mean, these are down 0 milliseconds, 3 milliseconds. I still don't like that. That's too slow. But we're doing a lot of inefficient things right now. So, all right, I can deal with that. We can, get make file there. We're clean. Okay. And with that, oh my goodness, this was a long one. I know it was. My apologies. I'm not going to cut this down. We're right at 4 hours. That's what it took to get it, and it is 2:30 in the morning for me. So I'm going to stop, and I'll at least start an upload. But again, overall, my intent is to document a non-trivial project being created start to finish. And sometimes it involves stuff like this. As always, thank you for joining me. Hope it's been good. Thank you.